All right, welcome back. We are on to problem 15 of practice exam 2. The question is, when air expands adiabatically, that is without gaining or losing heat, its pressure P and volume V are related by the equation P times V to the power 1.4 equals C, where C is a constant. When somebody tells you C is a constant, think of a number, your favorite number, say 5. Why do I say that? Because for our purposes, we typically take derivatives. So when you have a constant, say number 5 or 10, whatever, its derivative will be 0, no matter what number you choose. Okay? So that's important to note. It's a constant. Now, suppose that at a certain instant, the volume is 310 centimeter cubed. Centimeter cubed is also called cc, by the way, right? And the pressure is 91 kilopascals. kPa stands for kilopascals. And is decreasing. So who is decreasing? Pressure is decreasing at the rate of 9 kilopascals per minute. At what rate is the volume increasing at this instant? Okay, that's the question. So what's the question? What rate is the volume? In other words, dV dt. That is the question. We are told from the units here, notice, decreasing rate of pressure, kilopascals per minute, tells me time is in minutes. I'm given this equation, PV power 1.4 equals C. At a certain time, at a certain moment, right, volume is 310 centimeter cubed. Pressure is 91 kilopascals. My pressure is decreasing. So decreasing tells me it's a negative 9 kilopascals per minute. Question is, what is dV dt? So let's figure this one out, right? Take the derivative of the given equation. Keep in mind, C is a constant, your favorite number. No matter what your number is, derivative of a constant is 0. On the other hand, so right hand side is 0. So that was easy. So on the other hand, left hand side has product rule. Derivative of the first, second as it is, plus first as it is, derivative of the second. So let's go. Derivative of the first. Derivative is written in fraction form, dp dt. Second as it is, v power 1.4 plus first as it is, derivative of the second. So notice you will need power rule there, right? Power rule tells me bring down the 1.4, reduce the power by 1. So reducing 1.4. So 1.4 minus 1 is 0.4. And notice we are taking derivative with respect to time dt. So I still need to write dv dt. Alright. So this is my differential equation. So don't forget, I'm taking derivative with respect to t. And that is why dp dt, dv dt. Alright. Okay, so far so good. Now let me plug in all these values. Question is to find dv dt. The rest we already have. So dp dt is negative 9. V is 310. And we are going to take power 1.4. All right. Plus P is 91. There is a 1.4. And V is 310. Power 0.4. All right. Almost home. Fraction dV dt is 0. I need to solve for dv dt. So get all of this to the other side. First step. Okay. So I'll keep this on one side. And I'll take this to the other side. Mind you, because this is negative 9, on the other side, you become 9, 310 power 1.4. All right. So far so good. Now what else? I want to solve for dv dt. So fraction dv dt equals, I have this over this. All right. So let's see, that's a big fraction. On the top is 9, 310 power 1.4. On the bottom, I have 91, 1.4, 310 power 0.4. Okay, that's looking good already. Can I reduce anybody? Yes, I can. 310 1.4 and 310 0.4. So you understand, the exponents I have to take subtraction of, correct? So in other words, I have this expression. Let me cut and paste so you can see, right? 310 0.4 takes care of 0.4. So all I'm left with here is 1, and this denominator part goes away. Okay, so power 1 is power 1. What is there to say, right? So I don't need to write that one. So that's it. So let me write down the expression. So notice, whenever I have a quotient I need to fit in, it's easier to start by numerator divided by denominator. So I will say 9 times 310 over 91 times 1.4. Now let's try. It worked. All right. See you until the next problem.